Good day class, I'm Sir Gary and welcome to our video lesson. And for today's topic, we will be discussing about polynomial functions. And at the end of this lesson, you are about to illustrate polynomial functions including the graphs. Before we start, let's have a short recall. Identify whether each of the following is a polynomial expression or not. You have 10 seconds to answer. Your timer starts now. Alright, time is up. If these three are your answer, you are correct. These are example of polynomial expressions, and these are not an example of polynomial expressions. Always remember, polynomial expression is a group of variables, coefficients, and constants, and it doesn't have a equal sign. How about this one? Is this a polynomial or not? If your answer is yes, you got it right. It is an example of polynomial, and we call it polynomial function. And polynomial function is a function defined by a polynomial expression. It has a f of x. To begin with, let's start defining a polynomial function. A polynomial function is a function that involves only non-negative integer powers or only positive integer exponents of a variable in an equation like the quadratic equation, cubic equation, etc. Also, polynomial functions are expressions that contain variables of varying degrees, coefficients, positive exponents, and constants. A polynomial of degree n is a function of a form. This is the standard form of polynomial function, where a sub n minus 1 up to a sub 0 is called coefficients, and real numbers. A sub n is called the leading coefficient, n is called the degree or a non-negative integer. Next is a sub 0, which is a constant term. Let's have our illustrative example 1. From this example, we have f of x is equal to 4x cubed minus 3x squared plus 2. And this is an example of polynomial function. Our leading term is 4x cubed, and the degree is 3. 3 is the highest power of x in the formula. And the leading coefficient is 4, and the term with no variable is 2. So 2 is our constant. Remember these types of polynomial functions. In zero polynomial functions, we have 0 degree. For the linear polynomial function, we have 1 degree. For quadratic polynomial function, we have degree of 2. For cubic polynomial function is 3 degree. And for quartic polynomial function is 4 degree. Take note, p of x or f of x can be written as y. Example, p of x is equal to a squared plus bx plus c, or it can be written as y is equal to a squared plus bx plus c. For our illustrative example number 2, look at this. F of x is equal to 4x plus square root of x minus 1. Do you think this is an example of polynomial function? Definitely not. Why? Because x can be written by x raised to 1/2, and x cannot be inside a radical. Next, f of x is equal to 3x squared plus 3x raised to negative 2 minus 1. Do you think this is an example of polynomial function or not? You are correct. This is not an example of polynomial function. Why? Because no negative exponent are allowed in polynomial function. Next, f of x is equal to 5x raised to 4 minus x squared plus 3 over x. Do you think this is an example of polynomial function or not? You are correct. This is not an example of polynomial function. Why? Because x cannot be in the denominator. Next example is f of x is equal to 5x raised to 1/3 plus 3x squared minus 2. And this is not an example of polynomial function. Why? Exponent cannot be in a fraction form. Next, let's proceed to the graphs of polynomial functions. First, the graph of any type of function must pass the vertical line test. An equation defines a function if each vertical line in the coordinate system passes through at most one point on the graph of the equation. If any vertical line passes through two or more points on the graph of an equation, then the equation does not define a function. For our figure 1, this is the graph of function because any vertical line crosses only once. And for our figure 2, this is not a graph of a function because you can draw a vertical line which crosses twice. Look at this. Next, a graph of polynomial function is continuous. This means that the graph of a polynomial function has no breaks, holes, or gaps. This is an example of continuous, and this is not an example of continuous. Why? Because it has a break line. Next, a polynomial equation of the nth degree cannot have more than n roots. This is only means that the graph cannot intersect the x-axis more than n times. Look at this example. Next, a graph of a polynomial function has only smooth, rounded turns. A polynomial function cannot have a sharp turn. Look at this example. From our figure, this is an example of smooth and rounded turn. Next is an example of function having a sharp turn. Therefore, from this figure, this is not an example for polynomial function. Next, this is the graph for linear polynomial function. Next is for quadratic, cubic, quartic, quintic, sextic, or hexic, so on and so forth. Now, let's have a review. Which is a polynomial function? A. P of x is equal to 4x squared plus 2. B. G of x is equal to 4x raised to 1 half plus 3x minus 4. C. N of x is equal to 2x squared plus square root of x. D. P of x is equal to 3x raised to negative 2 plus 1. If your answer is A, you are correct. Why? Look at this. For our letter B, exponent cannot be in a fraction form. Next, for our letter C, x cannot be inside a radical. For letter D, no negative exponent are allowed. Next, which of the following graphs below are not a polynomial function? A. 1 and 2, B. 2, C. 4, or D. 2 and 4. If your answer is letter D, you are correct. The graphs of 1 and 3 are graphs of polynomial functions. They are smooth and continuous. The graphs of 2 and 4 are graphs of functions that are not polynomials. The graph of function 2 has a sharp corner. The graph of function 4 is not continuous. Why? It has a broken line. For our generalization, polynomial functions p of x or f of x can be written as y. The degree of polynomial is defined as the highest power of the variable in the polynomial. In particular, for an expression to be a polynomial term, it must contain no square root of variable, no fraction or negative powers on the variables, and no variables in the denominators of any fractions. Next, remember that the graph of polynomial function whose degree is 0 or 1 is a line. The graph of a polynomial function is a parabola if it is a quadratic function. Every polynomial function with real coefficients has the set of real numbers at its domain. Hence, it is continuous function. This means that the graph of a polynomial function has no breaks, holes, or gaps. A graph of a polynomial function has only smooth, rounded turns. A polynomial function cannot have a sharp turn. And that's all for today. I hope you learned something. Thank you and God bless. Stay safe.